Hello, my name is Kennedy Nguyen. I'm the lab manager for the Imaging and Microscopy Facility at UC Merced. My job is to train students and faculty and staff for using the equipment at the imaging facility, such as confocal microscopes, electron microscopes, and different instrumentation to assist in materials characterization. As you can see, this is a wall of the different grants that different faculty on campus has used to provide instrumentation for our lab. So I hope you enjoyed this virtual tour. Hello, this is our first room. This is our sample preparation room. Since most of the equipment we use in here is for electron microscopy, we need to make sure the sample is conductive, grounded, and can survive in a vacuum. A lot of materials don't fit that criteria, like for plants aren't the most conductive material. So this instrument here is our critical point dryer. What we could use, if we have a plant sample, we could critically dry the sample, make sure it can remove all the water moisture so then it can survive better in vacuum. And then we could use one of our other instruments. We could coat the sample after it's completely dry, and then we could analyze it with electron microscopy. This instrument here is our plasma coater. To add materials onto the different stubs or different grid materials, we need to make hydrophilic or hydrophobic. So this is how we treat our samples with different gases, oxygen, hydrogen, argon, to treat the sample surface so we can analyze the sample as well. This machine over here is our carbon coater. If the sample is not conductive, then we could add a thin layer of carbon coating on top of it to make it more conductive for electron microscopy. This is our Zeiss Gemini SEM 500. These are a couple samples we have here. We're going to use on the microscope. We have some plant samples. We critically point dried them, and then we coated them with gold. And now we're going to look at put it in the SEM and have a look at it. Okay, so we already have our sample inside the sample chamber here. Earlier we had to vent the chamber. Since it's always in vacuum, put the sample in and then pump the chamber. So now that it's already pumped, we have stage controls here, moving up the sample. You can see our sample here. And we're moving it close enough so we get a higher resolution imaging depending on the working distance here. So first we'll go to low mag. Check out a zoomed out to see or orient ourselves on the sample. Here's like a dirt particle or something because you see it's charging. Usually the black and white usually indicates some kind of charging. Okay, so we have that. I'll save it. And then our images will appear over here. So you can keep track. This is our picture of our sample on the stage. And then we have a picture of the leaf here. So this instrument here is our Quanta 200. It's from FEI, or now Thermo Fisher. This is our environmental scanning electron microscope. It also is equipped with an EDX detector, which is energy dispersive X-ray analysis. We're when we hit our samples with electrons, not only do electrons bounce off the sample, but there also produces X-rays, and these X-rays will be characteristic of what kind of material that the electrons are hitting. So analyzing the X-ray signal from the electron microscope signal, we could analyze what kind of element the material is. So here we have our sample inside. KV energy is going up right here. That's auto brightness and contrast. Okay, there you go. Now we're seeing stuff. So let's increase the pacing. So I'm gonna focus, making sure we're seeing something. So we have our sample. Let's zoom in there. So this is a map I did before. So this is a view of the sample, and then these are the different spatially where each of the elements are. So there's light, so you don't see a lot of carbon, so you don't see the signal. You see oxygen. This is where the oxygen is located. Magnesium. And you can see aluminum, silicon. Some of these there's not as much signal from these elements, but they're there. For the calcium, you can see, so when the electron beam hits the sample, all the X-rays have to go directly to the detector. But if the electron goes into a hole, and the X-rays are formed, if it hits the sample, then it won't go to the detector, so then you'll see shadows inside the sample. So that's why the image of the sample, see all the holes here? And in these maps here for the elements, we can see the holes representing some of the electrons or X-rays that didn't make it to the detector. Only the ones on the surface did. This is our X-ray diffractometer. This is used to analyze the crystal structure of different materials. We could analyze solid materials here. I have a silicon wafer on this disc holder here. Or we could also analyze powdered samples. So if you have a powder of silica powder, nanoparticles, you could put the powder here, flatten the surface, and then put it into the machine to analyze the crystalline structure of the material. So I'm going to put this into the machine, and we're going to see what kind of crystal structure it has. So we open the doors, add the sample slot. Okay. Close the doors. So what's going on here? So the X-ray is going to hit the sample, and then we have a detector that's on the side. X-rays are always going to be scattering in different directions, but the detector is going to detect at which angle the X-rays are going to bounce off of, and at every angle it's going to collect the angle. As you can see, the arms are moving, and then we'll get corresponding spectrum, 35, 55. At these different angles, we see diffraction occurring. This is our transmission electron microscope. It's a little different from the two scanning electron microscopes that you guys saw earlier. The scanning microscopes scan on the surface of your sample. For this one, the transmission electron microscope needs the electron beam to penetrate through the sample, so then we'll see the sample. So the kind of size that we need is about a 3 millimeter disc. So you see these grids here. This is about the approximate size you'll have for the holder. So I'm going to take out this holder so you can see the how thin and how small we have to put on the grids, so then we can put it into the microscope. To put the grid on this sample, we use this tool here. Insert, lift up sample here. And then we would grab one of these tweezers here. Then if I would grab I'd grab one of the TEM grids, and you could see I'll place it onto here, center it. So I'm going to align the small pin to this arrow key here. Have the pump start single tilt selected. You can see we could use different holders, the cryo holder, double tilt holder. We use the single tilt here. We'll just have this pump for 2 minutes. So this is the interface for the TEM software. So since we have the sample inserted, we'll open the column valves to let the electron beam go through. So you can see this is typically on the TEM grid, you have these meshes. This is a copper mesh, and then you have your sample grid or your sample in between this layer here. And then we could zoom in any of these sections here. This is our confocal microscope. This is for imaging samples with fluorescence. I have the sample in there. I'm adjusting the illumination so I could focus. Sample there. All right, so once I have the illumination set, okay. So I turned on the different lasers on earlier. So now we're gonna check if there's any fluorescence on the sample using the different lasers. So some of it's a little too bright, so I'll adjust that. The red, the green, and what's fluorescing blue. So you could locate, based on which, whatever's fluorescing, you could ID whatever material. So let's say if you had nanoparticles, and you could have them attached to specific parts of the tissue and identify where they are. So you can see the green is located here, red is located here, and you all basically quantify whoever is fluorescing with what it may be potentially based on the fluorescence there. Okay. And that concludes our tour. I hope you enjoyed our virtual tour of the Imaging and Microscopy Facility.